9.1 polygons in the coordinate plane. All right, so example 1. What formulas can you use to identify properties of figures on the coordinate plane? A, which formula can be used to find AB? All right, so on A, we are wanting to find the distance between A and B. So to do that, we would use the distance formula. And a reminder, the distance formula you take the square root of x1 minus x2 squared plus y1 minus y2 squared. Okay, so then to find the distance of AB, we're going to use the distance formula. I'm taking the square root of x1 minus x2. It doesn't matter which x I use first as long as I'm consistent when I do the y. So for this one, I'll just do the a first. So 1 minus the 3, square that. And then we will add our y's. Because I started with my a, the x from that, I have to start with my a, the y from that. So 6. 6 minus the 1 squared. Once I do the calculations on that, I will find that AB will equal the square root of 29. Okay, B, what point bisects AB? So we want to find the center of that line AB, and to do that, we need to find the midpoint. So our midpoint formula we are essentially taking the averages of our x's and our y's. So I would take my x's and add them together, divide that by 2, and then my y's, divide that by 2. And that will give me my midpoint. All right, so for B here, to find the bisecting point, I want to find the midpoint of AB. Okay, to find my midpoint, I'm going to take my x's and add them together. Again, it doesn't matter which x I start with, as long as I'm consistent. So 1 plus 3 divided by 2. My y's, 6 plus 1 divided by 2. So that will end up simplifying and giving me the point 2 and then 7/2. Okay, C. Why do slopes in this line here, these should be above. Okay, so why do the slopes of line AB and line BC show that the measure of angle ABC is 90? Okay, so we want to find the slopes of those two lines. All right, to find our slopes, we want to put our y's on top. We're subtracting our y's. So 1 minus 6 over 3 minus 1. Okay, again, for slope, it doesn't matter which point you start with as long as you are consistent. Okay, so once I simplify this, my slope for AB, I will end up getting -5 halves. All right, slope for BC. Three minus 1 over 8 minus 3. That's going to simplify down to 2 over 5. So in order for it to make a 90 degree, so they want us to show that it's creating a 90 degree. In order to make a 90 degree, that means that we are forming perpendiculars. So I want to check to see if those two slopes are perpendicular. A perpendicular slope, so a perpendicular slope ends up creating negative reciprocals. Okay, so negative reciprocal, that means that if I have a -5 halves, the negative reciprocal of that, we flip it to get us 2/5, and because it's already negative, the negative of a negative is a positive. So these two are negative reciprocals, so yes, this forms a 90 degree. Okay, let's look at our try it. Given triangle ABC, what is the length of the line segment connecting the midpoints of AC and BC? All right, so the first thing we want to do is we want to find these midpoints. So we want to find those midpoints, so we're going to use the midpoint formula to find those points. So first thing we want to do is find midpoints. After we have found those 2 points, then we're going to use those to find the distance between them. All right, so we're going to find midpoints. We'll start with AC. Okay, again, to find my midpoints, I add them together, divide by 2. So 1 plus 3 plus 8. 1 plus 8 divided by 2, 6 plus 3 divided by 2. My midpoint for AC will end up being 9 halves and 9 halves. BC, we're going to find our midpoint. So I'll end up with 11 halves and 2. So I have my midpoints. Now I want to find the distance between those two. So I figured out these midpoints. This midpoint was 9 halves and 9 halves. And this point is 11 over 2 and 2. So I found those 2 points. Now I want to find the distance between those. So I'm going to take those 2 points and I'm going to plug them into the distance formula. So I'm going to take my x's and subtract, and then square, and then my y's. Simplify. And I'll end up with the square root of 7.25. And that is the distance between those 2 midpoints. All right, let's look at example 2. Is triangle XYZ equilateral, isosceles, or scalene? And we need to check these to see what it is. All right, for an equilateral triangle, all of our sides would be equal to each other. Isosceles, 2 of the sides would be equal. Scalene, none of them are equal. So we want to find the length of each of the sides. So we're going to use our distance formula to find the length of each side. So I'm going to start with XY. So I'm trying to find this side length. I'm going to use my distance formula. Okay, once I use my distance formula to find the distance of that side, I get the square root of 52. So this side right here is square root of 52. I'm going to change my color so we can see and follow along a little better. Next we'll do YZ. So I'm going to do this side right here. Again, I'm using distance formula. So that's going to end up simplifying to the square root of 13. So this side is square root of 13. So far, I know it can't be equilateral because I have 2 different measures. So it can't be equilateral. It could possibly still be isosceles or scalene, depending on what that third side measures. So we're going to find that third and final side, XZ. So we're looking for this final side right here. And that will simplify to get us the square root of 65. So none of those sides have the same measure, so it cannot be an isosceles. We know that this has to be scalene. All right, B, is XYZ a right triangle? So we want to see if XYZ is a right triangle. The way we can do that, I know I can use Pythagorean theorem on a right triangle to find a missing side. So I'm going to plug those 3 sides into the Pythagorean theorem to see if they equal each other and it gives me a true statement. Okay, so let's plug these into Pythagorean theorem. So we will do XY first, which is the square root of 52 squared. My XZ has to be my hypotenuse side, so I'm going to use YZ next. And they have to equal the hypotenuse, which is that XZ, so square root of 65 squared. Once I simplify this, I will end up with 65 equals 65. That is a true statement, so this is a right triangle because it did satisfy the Pythagorean theorem. Okay, let's look at the try it. All right, they're giving us the vertices for triangle PQR. We want to figure out if it is equilateral, isosceles, or scalene. So again, we want to find the distance of each of the sides to see if they are all equal, if 2 of them are equal, or if none of them are equal. So I'm going to start with PQ. Plug that into the distance formula. Okay, so right now I'm using P and Q to find the distance. Once I simplify, I get square root of 40. All right, next I will find PR. That will simplify to the square root of 32. And then finally QR. And that's going to simplify to the square root of 40. So on this, I have two sides that have the same measure. So if I have two sides that are equal to each other, that means that this is an isosceles triangle. Okay, if all of those distances ended up being that square root of 40, then it would have been equilateral, but because only two of them are equal, it is isosceles. All right, for part B, we want to check to see if this is a right triangle. So to do that, we're going to check our slopes. And remember, to be right triangle, we need perpendicular sides. So we want a slope or a set of slopes that are negative reciprocals of each other. So we're going to find each of the slopes and see if we have negative reciprocal of one of those slopes. All right, so we're going to check PQ. So my slopes. Okay, so my first slope is negative 1/3. PR. Okay, I will get negative 4 over negative 4, which will reduce down to 1. All right, and then we want to find the slope for QR. So far, I don't have any slopes that are negative reciprocals of each other. So we want to check our last one. Okay, so that one doesn't give me a negative reciprocal as well. So because there are no negative reciprocal slopes, that means that this is not a right triangle. All right, so we're on to example 3. We want to figure out what type of parallelogram RSTU is. So the first thing we want to do is we want to find our side lengths. So we want to figure out if they have all the same side lengths. If they have all of the same side lengths, then we know that it could be a rhombus or a square. So first thing we want to check is to see if all of our side lengths are the same. Well, I can kind of see it doesn't look like they have the same side lengths, so I'm going to check a set of the side lengths that don't look the same. So I'm going to first check ST. And we're going to check that by using the distance formula to find the length of the sides. So once I simplify that, ST will get me the square root of 52. Next, I want to check RS. And again, if I wanted to check other sides on here, I could. Those are just the two that I'm using. Right, so RS is going to give me the square root of 10. Those are not equal to each other, so my side lengths are not all equal. So all four sides are not all equal, so I know that it cannot be a rhombus or a square. Okay, so next we want to see if it is a rectangle, and to be a rectangle it has to have 90-degree angles. So we want to check to see if this has 90-degree angles by checking the slopes. Again, to be 90 degrees we have to form a perpendicular, which would give us negative reciprocal slopes. So I'm going to find the slope of ST. And I'm going to end up with negative 2/3 for that slope. Then I'll find the slope of RS, and I'm looking to see if it has negative reciprocal slope. So if it was negative reciprocal of that negative 2/3, I should end up with 3/2 for my slope. So if this is not 3/2, then it is not a rectangle. So let's go ahead and finish finding this slope. That's going to get me just 3. Okay, so that's not 3/2. These do not have negative reciprocal slopes of each other, and it is not forming 90 degrees. Okay, so this is not a triangle. Or, sorry, not a rectangle. Okay, so if it's not a rhombus, not a square, not a rectangle, that means it is just a parallelogram. Okay, let's look at the try it. All right, so this one, they give us a parallelogram and they are giving us the 4 coordinates. We want to find out if it's a rhombus. So to be a rhombus, all of our 4 sides have to be equal to each other. So we're going to check to see if all 4 sides are equal to each other. So I'll go ahead and start with AB. Again, to check our side length, we use the distance formula. We're finding the distance between the 2 points. Once I simplify this, I will get 2 square root of 13. Okay, so if I want this to be a rhombus, then my next, or all of my side lengths have to be that 2 square root 13. So let's check another one. All right, that's going to end up getting me square root of 13. Well, those are not equal to each other, so I know that this cannot be a rhombus. All right, B is ABCD, a rectangle. So now we want to check to see if it's a rectangle. To be a rectangle, we already know that we have different side lengths. To be a rectangle, it has to form 90 degrees. So we know that we need to have perpendicular slopes. So we're going to check our slopes. So my slope of AB so that gets me 2/3. So again, in order to have negative reciprocal slopes, I have this 2/3. I'm looking for a negative 3/2. That would be the negative reciprocal of 2/3. So I'm looking for negative 3/2. So let's go ahead and find our slope to see if that gives us the negative 3/2. So we'll find our slope of BC. And that does get me the -3/2. So they have negative reciprocal slopes. It's forming a perpendicular. So yes, this is a rectangle. All right, example 4. Is ABCD a trapezoid? All right, so to be a trapezoid, we need a set of parallel sides. So to check to see if I have a set of parallel sides, I want to check the slope on all of my sides to see if any of them have the same slope. So let's check our slope. So we're finding our slopes. I'll find my slope of AB. And we'll find my slope for BC. So far, I don't have any equal slopes. And then our last one. And I end up with 1/2. So on this one, I do have congruent slopes for side BC and AD. So those sides are parallel. So because AD and BC are parallel, it is a trapezoid. Okay, next B is JKLM, a kite. Okay, a kite does not have any right angles, but it does have sets of congruent sides. So to be a kite, this side will be congruent to this side. This should be congruent to this. So I should have those sets of congruent sides. So I'm going to check the side lengths to see if they are equal and congruent to each other. To check the side lengths, I need to find the distance between points. Okay, so I'm going to start by finding my distance for JK. That's going to get me 5 for that distance. Okay, so this one is square root of 10. This is 5. We'll check our last two sides. Okay, that does give me the same measure, so LM, this one is also square root of 10, so far it's looking good. Let's check our last side. This last side should end up equaling 5, but we want to check to make sure. Okay, and once we simplify, we will see that it gives us 5 for that side. So because these have two sets of congruent consecutive pairs, then it is a kite. right, let's look at the try it. Is the quadrilateral a kite, trapezoid, or neither? Okay, so kite, we would have congruent consecutive pairs. Trapezoid, we're going to have parallel sides. Neither, we will have neither of those things. So we're going to check our slopes first to see if we have any parallel sides, to check to see if it is a trapezoid. So let me check my slopes. Okay, so far I do not have any parallel sides. Okay, I do not have any parallel sides. That means that it cannot be a trapezoid because I would have to have one set of parallel sides. All right, next we're going to check to see if it is a kite and if it has congruent consecutive pairs. So we have sides that are congruent and equal to each other. So we're going to check our side lengths by finding our distance. Okay, so this measure would be 4. Square root of 26. Okay, so for RS, we want this one to equal square root of 26. So let's check to see if that's what it gives us. All right, once I simplify, I will find that it gives me the square root of 26. Last, we're going to check PS. For PS, we want that to have the measure of 4 to match our QP. So let's check to see if this gives us 4. And it will give us 4. So we have 2 sets of congruent sides. So this is a kite. Okay, B. We want to check to see if this quadrilateral is a kite, trapezoid, or neither. So again, we want to check the slopes to see if we have any parallel sides. So far, I have not found any parallel sides. Check our last one. Okay, I did not find any parallel sides, so that means it cannot be a trapezoid. So next, we want to check to see if it's a kite, if it has congruent consecutive pairs. So we're going to find our distances. That's going to simplify to the square root of 13. Check our next side. That equals 5. Square root of 5. So far I don't have any congruent sides. Okay, so I did not end up with any congruent consecutive sides, so this is neither a trapezoid or a kite. All right, our last example, example 5. Dylan draws up a plan to fence in the yard for his chickens. The distance between grid lines is 1 foot. Is 30 feet of fencing enough to enclose the yard? So we want to find the entire exterior of that yard. So we want to find the distance between each of the sides, and then we'll add them up to find the perimeter. All right, so we're going to find our distance for each side. All right, that first side is 10 feet. My second side, I will get 10 feet. And then my third side, I will end up with square root of 80 feet. We want to find the perimeter, so we're going to add all of those together. And that's going to get me approximately 28.9 feet. So the exterior perimeter of that fence, we need 28.9 feet. Well, he has 30 feet, so yes, he has enough fencing because the 28.9 feet is less than the 30 feet of fencing he has. Okay, part B. For a healthy flock, each chicken needs at least 8 square feet of space. What is the maximum number of chickens Dylan can put in the yard? All right, so to find how many chickens he can have, we need to find the area. To find the area, if we remember our formula for area, is 1/2 base times height. So we need to find what our height is. Okay, so I'm going to find the midpoint of AC. So it's going to be somewhere roughly in here. That's not actually accurate. I need to calculate it. So we're going to find the midpoint of AC. Okay, to find our midpoint, we take our two sides and add them together, or take our x's and y's and add them together, divide by 2. So our point is 6 and 4. Okay, to find our height, then we want to find the distance between B and that new point that we just found, our midpoint. So I'm going to find my distance between B and that new point. You can go ahead and call that point X. So BX. Okay, once I calculate that, I get square root of 80. Now I can use that to find my area. So our area of triangle ABC is 1/2 our base, which was our AC, which our AC we found to be square root of 80, and our height, which we found to be square root of 80. Once I calculate that, I get 40, and that's in feet. So our area of our triangle is 40 feet. If each chicken needs at least 8 square feet, and that's square feet, if each chicken needs at least 8 square feet of space, we're going to take that 40 square feet of space that we just found and divide it by the 8 square feet each chicken needs to find out how many chicken we can have, or he can have. And we will get 5. So Dylan can keep 5 chickens in his yard. All right, let's look at the try it. All right, they're giving us vertices for W, X, Y, Z. We want to find the perimeter. So we need to find the distance between each of those points. So W, X. I'll get square root of 34. XY. Get 7. YZ. Get square root of 26. So I've found all of my side links for W, X, Y, Z. We want to find the perimeter, so we're going to add all of those together. Okay, so once I add all those together, I'm going to get 20.93 is the perimeter. All right, B, what is the area of WXYZ? All right, so I want to figure out what type of quadrilateral WXYZ is. So I'm going to kind of sketch out these points. Try that again. To get an idea of what type of quadrilateral we have. So okay, and it's just a rough sketch. So I've got my quadrilateral, and I can tell that this is a trapezoid. I have two sets of parallel sides, or a set of parallel sides. So I'm going to use the area formula for a trapezoid. My area formula for a trapezoid is 1/2 base 1 plus base 2 times our height. So I want to find my height. So I'm trying to find the height of my quadrilateral. I can kind of pick any points I want to find that height. I'm going to pick, just to make it a little easier on myself, I'm going to pick the point they already gave me. And then I want a height, so I need it straight up. I want to pick this point right here, which would be 8, 9. Call that my height H. Okay, so I'm going to find that height by finding the distance of that. It's going to get me 5. So my height is 5. Now I can plug in my other side links to find the area of this trapezoid. All right, my base 1 is going to be the top, so XY. My base 2 would be that bottom, so ZW. And then we multiply that by the height that we just found. Okay, so now we're going to plug in those distances, those side links from above. So 1/2 times XY, which is 7, plus ZW, which is 3, times the 5 of the height. All right, once I calculate all of that, I'm going to get 25 for the area of WXYZ.